Hello and welcome to the Graphing Trig Day 3 Transformed Graphs video. So I was originally going to do this in all one big video, but I decided to split this up into parent graphs and transformed graphs. So in this video, we're just going to go over two problems transforming what we had talked about in our previous video. So make sure to go back and watch the parent graphs video. So let's get started. I'm going to be doing two problems from the Go Formative or from the blank note, so feel free to check that out. But right now we're just working on problem 3, which is y is equal to -2 times sine of x. So this is a lot like our parent graph. The only difference is that -2 out in front. So we're going to have -2 times sine of 1 times x minus 0 plus 0. So as we go through and find all of our features, our amplitude in this case, amplitude, there we go, is going to be 2. Remember, your amplitude is a distance, so it's always positive. We'll come back to that negative out in front, but our amplitude is just 2. Our frequency, oops, I don't know why I started typing frequency is 1. And our period, you know what, I think I'm going to actually do our period in degrees this time, since in our last video we spent some time talking about radians. So if we do this in degrees, we're going to take 360 divided by our frequency, or in this case 360 divided by 1. So our period is 360 degrees, that's how long it's going to take to repeat itself. Our phase shift is going to be 0. And our midline is also 0. So almost everything is exactly the same. It's just that our amplitude is 2, which means we've been vertically stretched by a factor of 2. So those are all of our features. Now when we are scaling, like I said, we're going to do our degrees instead of our radians. And our y-axis is also going to look a little, oops, that should be in black. It's going to look a little bit different than last time. It'll be a little bit taller because we want to go all the way up, we'll do this here, to 2. So let's see, I'll put my axis here. A -2. So we've been stretched out vertically, so we need to make sure that we have more of our y-axis shown. So when we're dealing with our scaling for x-axis, I'm going to do this in the same way that we did our radians, where every block was every pi over 4. But for us, pi over 4 in degrees would be 45 degrees, which would make this one 90. So I can think of it as every 2 blocks is 90 degrees, if you want to think of it that way. So that means that 2 blocks later, that's going to be 180 degrees. 2 blocks from that is going to be 270 degrees, and 2 blocks from that is going to be 360 degrees. So you don't have to mark in like every single block, as long as I get kind of every other or a rough kind of explanation of where everything is. That's all that matters to me. So feel free to pause at any time to make sure you have all of your scaling done. So we're done with our scaling. Let's see, the next thing I want to do is find my graphing interval. So how often am I going to have to make a mark? So my graphing interval is going to be my period divided by 4, or in this case 360 divided by 4. It's always going to be divided by 4. And that's going to be 90 degrees. So every 90 degrees, we're going to make a mark. Now, for us, 90 degrees means you're 2 squares over. If you scale differently, so for instance, if you scaled every block by 30 degrees instead of 45, that's totally fine. It just means that for you, 90 degrees is going to be 3 blocks. So you're allowed to choose your scaling however you want, just make sure that you are consistent with your personal scaling. So when we start graphing for sine, just a reminder, sine starts in the middle of the graph, and we don't have a phase shift, so we're just going to stay there. Now we're going to bring in that negative piece. So that negative, that negative right there means upside down. So instead of starting with going up, we're going to go down. Now when we're talking about our up and our down, we're going to start on our midline and then put in our kind of road lines for our amplitude. So let's count 2 up from the midline and then 2 down from the midline. So all of my points should be on here. So instead of starting here at this green dot and then moving up like we did in our last video for our parent graph, since we have that negative out in front, we're going to be moving down. So we're going to move over 2 squares, or 90 degrees, and then move down. So my next point will be right here. I'm going to move over another 90 degrees, or 2 squares, and then since we're down, the only place we have to go is up. So we're not going to go all the way up, we're just going to go to our next dashed line at 180 degrees. And then from here, we're going to move 2 over, or 90 degrees, and then move up. So we have to go all the way up. And then for the last piece, again, we'll move over 2 over, and then down. And I can see we've graphed 1 full period. It looks just like our parent graph, except it's been stretched out a little bit more, and it's upside down. So this is what the negative and the vertical stretch or the amplitude can do to your graph. Now, make sure you're also going in the opposite direction. We want to graph from negative 360 to positive 360. So since we were moving over right 2 squares, now we're going to move left 2 squares. And we're not going to go back down because then that wouldn't complete our graph. So we're going to move left 2 squares and then move up. And just make sure that you are continuing your pattern. Whoops, that got a little wavy. There we go. Pretend that's connected much prettier. There we go. Okay. And there you have our graph. So let's try just one more. So let's try problem number 8. Problem number 8 is y is equal to cosine of 1/2 times x minus pi over 2. So if we think about this in terms of our different colors that we use and our features, this is going to be 1 times cosine of 1/2 times x minus pi over 2 plus 0. So some of our features have changed up a bit. So now our amplitude is 1 again. Our frequency has changed though. Our frequency is now 1/2, meaning that we only get through half of one cycle in an interval of 2 pi. So when I go through and I find my period, in this case, I'm going to go back to dealing with radians because when I look at this phase shift, I can see that has a pi in it. So now I'm going to do 2 pi divided by my frequency of 1/2, which is the same thing as 2 pi times 2, or 4 pi. So now it takes 4 pi to go through one full cycle. It means it's kind of been stretched out horizontally. Next, our phase shift. I see that it says minus pi over 2 in the equation, so I'm going to put positive pi over 2, or that it's shifting to the right, because it's always going to go in the opposite direction of what we think. And then lastly, for the midline, again, that's going to be 0. So we have found all of our features. Let's do our axes. So I'm going to keep my scaling the same as I've previously been doing. However, the only difference is, as opposed to problem 3, instead of using degrees, I'm going to use radians. So let's see, let's do this here. Draw on my axes. Feel free to fast forward the video, but every 2 blocks is going to be pi over 2. I did this same scaling in my last video, so feel free to just copy it from there. Okay, we'll have 1 and -1, since our amplitude is the same. Speaking of, before we graph anything, let's just put in those lines for our midline. So this is still going to be on our x-axis. And our amplitude, so we'll count up 1 from our amplitude, and we'll count down 1 from our amplitude. So now we know where we're supposed to start, or where points are supposed to land. As to where we're supposed to start, well, our phase shift is at pi over 2. So we're going to be at positive pi over 2. We're going to be somewhere here. And we know, since we're dealing with cosine, we're going to start at the top. So we're going to start right here. But the question is, how far apart should my points be? How far apart should I look? Well, that's where I look to my graphing interval. So if I do my period divided by 4, it's going to be 4 pi divided by 4, or in this case, pi. So I'm going to have a point every pi distance. And for us, that's 1, 2, 3, that's 4 squares. So I'm going to have a mark every 4 squares. So what I'm looking for your graphing interval is this distance of pi, but if it helps you to write like the number of squares or what that means for you, that's okay. So for instance, if you scale this by pi over 6 instead of pi over 4, your numbers of squares might be different. But I know I'm supposed to go over 4 squares. So if I start here and I move over 1, 2, 3, 4 squares, the only place from there I can move is down. If I move over another 4 squares of 1, 2, 3, 4, I can move down again. Now this does go off the graph, so you don't have to have this point, but make sure that you show the graph kind of continuing with an arrow. Now that's all I can do for one side. Now if I go the other direction from this green point, or my starting point, we go over 1, 2, 3, 4 to the left, and down 1. And then we'll go over another 1, 2, 3, 4 to the left, and down 1. And again, you can continue past here, or when you're going, if you just want to do kind of like an arrow pointing up, that works for me. So you may have just had an arrow. So you can see it's really stretched out. We can't even see one full period unless we go a little bit over here from that start to finish. But this is what our graph looks like. So it's been shifted over with that green point, and it got really stretched out. So this is an example of a few different types of transformations you may see. We're going to be practicing a lot more tomorrow in class. Please ask questions if you have them. I look forward to seeing you in class tomorrow.